In today's lesson, we are going to look at solving literal equations. So this is something that would go back to what you learned in grade 9 and in grade 10. So hopefully this does seem a little bit more familiar than, say, maybe the factoring, because you only really did the factoring for 1 year. So hopefully this, this lesson may be a little bit easier. So formulas are equations that are expressed or that express a relationship between more than one letter or variable. So a formula can also be called a literal equation when it involves several letters or variables. So sometimes we need to use algebra to change the formula to a more useful equivalent equation, which is solved for a particular letter or variable. So basically, this jumble of words, what does it mean? It basically means that when we're given a formula or an equation, sometimes we may have to rearrange it to make it more useful to us. So whether this is to take an equation and rearrange it for something else because we're only given certain pieces or something along those lines, that's essentially what this means. Right? We're not really changing what it equals or the actual equation. We're just rearranging it so it looks slightly different, but it's still going to be the same equation in its purest form, I guess you could say, or just in general. It's still the same equation. It still does the same thing. It just is being looked at for something else. So a quick one. If we want to solve this equation, d equals rt, if we want to solve this for r, so basically maybe I'm given d and t, what those variables equal, and I want to solve for r. So what we can do is we can rearrange this equation, and how we do that is we use opposite operations, or we cancel things out. So what I need to do is, if I want to get r by itself, I want to get this variable all alone by itself. So I need to get rid of this t. I need to move that to the other side of my equation, or on the other side of the equal sign. There's different ways you can think of it. You can think of it as just moving the letter to the other side, and when we move something to the other side of the equal sign, we have to do the opposite operation. So if I move this t over, well, what's happening to the t right here? Right here, the t is being multiplied. So if I move this t to the other side, instead of multiplying, it becomes division. So by moving this to the other side, this becomes d divided by t, and r is left over. That's one way you can think of it. Another way, and since we have lots of space, another way you can think of it is canceling it out. It's the same principle essentially, except it maybe just involves a few more steps and shows kind of how we get from one to the other. If I want to cancel out t, well, how do I cancel out when I multiply by 1t? I would divide by 1t. To keep things balanced, because again, remember, we're not changing the equation. If I only did this on the one side, canceled out, and left it as d equal r, that's an entirely different equation. So we can't just do one thing to one side. We have to do the same thing to both sides. So if I divide the one side by t, I have to divide the other side by t. The one side will still cancel out, but then I'm left with d over t equals r. So again, either way we think of it, they still mean the same thing. So let's look at the next one. Solve p equals 2l plus 2w for w. Right, so this is our perimeter formula. Let's say we want to find the width given the perimeter and the length. So if I want to rearrange for w, I have to move a couple things. I need to move the 2l over, and then I need to get rid of this 2. Now what we want to do is we want to focus on the separate variables first, or the separate terms first. So because the w is attached to this 2, I'm going to deal with that part second. I'm going to move the 2l over first. P remains the same, because this was a positive 2L, when I move it over, it becomes minus 2L. The 2W still remains. Now I can focus on getting rid of the 2. I can get rid of the 2 by doing one of two things. I can move it over, or again, I can think of canceling it out. If I move it over, it goes from multiplying by W, or multiplying by 2, to dividing by 2. Now, one thing we want to keep in mind is that when we move something over, it affects everything on that side. So if I move the 2 over and it becomes division, that means everything on that side is divided by 2. And the W is left by itself. So when we move something to the other side, it does affect everything on the other side. That really only applies for the multiplying and dividing. We want to be careful of that when we move things to the other side. If I go to solve Q equals C plus D divided by 2 for D, again, I want to isolate this and get it by itself. There's a couple things we have to work at first. We have to get rid of the C and the divide by 2. Now, because everything is divided by 2, I want to get rid of that first. And we'll talk a little bit about this at the end of how do I really figure out where I start with, or what do I start with. For right now, we're going to get rid of this divide by 2. So if I move this over to the other side, instead of dividing by 2, it becomes multiplied by 2. So 2 times Q equals C plus D. Now I want to get rid of the C, so I'm going to move that over. It becomes 2Q, we could say, and we don't really need to show the brackets because it's implied that there's multiplying between them. 2Q minus C equals D. Because when we move the C over, it goes from positive to negative, or from addition to subtraction. And now we've rearranged for D. For 4, again, same idea, we want to get T by itself. Now this is a little different because T is on the bottom, so we have to actually move T first and then work to get it by itself, because right now it's on the bottom. So we can move everything on top, but I want T on top as well. So when we're trying to isolate for the variables, we want it by itself, but we also want it on top of our fraction. So let's move the T over first, actually. So let's move this over. It goes from dividing by T to multiplying by T. So TV equals 3K. Almost sounds like a 3K TV, but moving on. If I want to get rid now of the V, because I want to get T by itself, which is our goal for this question, I'm going to move the V over, and it goes from multiplying by V to dividing by V. And again, I now have T by itself, so I've solved this equation for T, or I've rearranged for T. Now we're getting a little bit more complicated. Right, we have more variables, some letters in there, but we're still going to focus on the same thing. I'm going to move this 360 up, because again, I want to get rid of that dividing by 360. So we get 360a equals pi r squared s. Now this one we have multiple things to get rid of. I have the pi and the r squared that are both multiplying with s. Because I want to get s by itself, I am going to have to get rid of these two terms. But which one do I start with? Well, when we think of multiplying, we might remember that when we multiply, order doesn't matter. So it doesn't matter if I multiply s by pi or if s by r squared first. Right? I can rewrite this as r squared pi times s still means the same thing. So because I can do I can do either step first, and because order doesn't really matter, I can actually move both of these over to the other side at the same time. Because it's the same operation, I'm going to end up doing the same thing anyways. So if I move both of these over to the other side, instead of multiplying, they become division. So that means 360 times a divided by pi r squared is equal to s. Now, if we were to do that step by step, say we started with the 360a equals pi r squared s. We move the pi, say we move the pi over first, we get 360a divided by pi equals r squared s. Then we move the r squared over, 360a divided by pi and r squared. We move that to the bottom. So either way, we still get to the same point or the same final answer, whether we do it in one step or two. Whatever you choose to do is up to you, as long as you're comfortable and you understand what you're doing. For 6, I want to solve a equals a plus b times h divided by 2 for little a. So I want to try to isolate this. Again, in our previous examples, when we were dividing by 2, or dividing by something, we wanted to get rid of that first. We want to get rid of our fractions first. So we move the 2 up. It becomes 2a equals a plus b times h. Now what we have to do, we have to get rid of the multiplying by h. So I need to get rid of the multiplying by h. So I'm going to move the multiplying by h over, and when I do that, it goes from multiplying to dividing. Final step, to get a by itself, I'm going to move the b over. When I move the plus b over, it becomes minus b. So 2a divided by h, and then we minus b from that, and we're left with a. So again, multiple steps there, but again, how did we really start, or what did we really start with? Well, some key things we have to remember. Right, you could remember the term opposite operations, because that's what we're doing when we cancel things out or when we move them to the other side. You could think of the term balance. If you're canceling out and you want to, you need to make sure you balance it, do the same thing to both sides. You might also think of, well, where do I start? How do I know what to start with? Well, you use reverse bedmass. So what we do, in order of where to start first, we deal with any subtraction or addition. Because reverse bedmath is Sam Deb. So we focus on any subtraction or addition, then move on to multiplication. Multiplication or division, then exponents and brackets. Now that generally only applies when you have what we call a two-step equation. So it might not always be like this, because we also want to get rid of fractions first. Get rid of fractions first, and actually then we get rid of brackets. Then we worry about that. So actually, let's move this just so we don't get confused. Oops. So we actually look to get rid of fractions first. We look to get rid of brackets, and then we use reverse bedmass to kind of help us from there. And so again, that's really when we have multiple operations going on. It may be easier sometimes when you have equations like this. Maybe you prefer to actually put in or substitute in all the information you have and then try to rearrange. And maybe it's easier for you to rearrange when you're dealing with numbers rather than letters, which is okay as well. Sometimes that may be a little bit tricky depending on what numbers you have, but again, that may be a personal preference. So the key thing from this is just understanding how to rearrange equations in order to find or have them help us find other pieces of information. We're not changing the equation in itself, we're just rearranging it so it looks slightly different, but it still means the same thing.